Alright, let's go ahead and get started here. And I want to start by reviewing over a formula I gave you yesterday to add to your area formulas, though it wasn't really a formula for a specific shape, but rather a formula that would allow you to work with two similar polygons and their areas. Now we already know if I've got, for instance, two rectangles specifically, Kendall, I could compare those two rectangles with what? Right, that's for two rectangles specifically, or Genesis, two parallelograms, for instance.
PL equals over P prime, no, PL prime equals BH over B prime, H prime.
There we go, same thing as the rectangle. For that matter, Ethan, I could compare the areas of two triangles with what proportion?
TR equals, oh yeah, COT equals B prime.
I'm going to say, you're making this really hard. It should be really easy by now. And right, so for all of these figures, but again, the rectangles didn't have to be similar, right? Or are rectangles always similar? Thoughts?
Technically, rectangles are always similar.
Sometimes. Their angles are always equal, but their sides are not necessarily proportional. So this is true of rectangles, whether or not they're similar. Parallelograms, whether or not they're similar. Triangles, whether or not they're similar. But for all similar polygons, how would I compare their areas, Jamie?
Area is to area, as side squared is to side squared, as perimeter squared is to perimeter squared.
There we go. Class, say that with me. Area is to area, as side squared is to side squared, as perimeter squared is to perimeter squared. Now, of course, if you just want to compare sides and perimeters, since they're all squared, you can take the square root of all of them, and you might remember perimeters to perimeter, sides to side, right? But when you're trying to compare areas, we basically would say then that this ratio of areas is equal to the square of the ratio of similitude. Okay, so this is true for all similar polygons. Let's quickly run through, though, our other area formulas we had. We kind of already referenced some of these, Chris, like, for instance, the rectangle.
Oh, PL, or no,
rectangle.
R equals BH.
And we did talk about one that started with a P. That would be the
PL equals BH.
which is for a
parallelogram.
parallelogram. We also had the square,
SQ equals S squared.
and we had triangles,
T equals half of BH.
and we had trapezoids.
TR equals half of H times the sum of B plus B prime.
Excellent. Or we could say that trapezoid equals
interesting. Half. Is it half of it's something to do with bases? Is that close to
Genesis
equal?
HM. Hence the machine kept doing.
Why no one likes you.
Trying to cheat on the trying to cheat here. Fortunately, it wasn't a test or question. It's okay. Let's see. We also had the right triangle, Audrey. And we also had a formula for the rhombus. Quentin?
RH equals 1/2 HM? No.
No help, anyone?
D1, D2.
D1, D2. Diagonals, remember? Question, Chris?
Yes. So on that T is to T prime, yeah. Isn't it supposed to be half of BH?
Well, remember we said technically there are 1/2s, but the 1/2s would cancel.
Yeah,
so that's why we don't need to include them. Good question. So again, these are our formulas for just a single figure. And this is really where you'd want to start. Even if they were comparing maybe a triangle and a square that were equal or something, you'd still want to come back to these area formulas that you've memorized. Comparing figures, if it doesn't say they're similar, you could still compare these figures using these formulas. But for similar polygons, we would use this. Now, notice that means SQ is to SQ prime is S squared is to S prime squared. But of course, all squares are similar, right? So squares are always similar. They would automatically fall into this if you try to put square to square, side squared to side squared. The only reason we don't get into trapezoids is they're a little bit harder to get into, so many different parts to them. Right triangles really just a spin-off on triangles themselves. And I suppose one might argue that rhombus is to rhombus as D1, D2 is to D1 prime to D2 prime. Of course, the 1/2 would cancel. Really don't do a whole lot with those. But this is what we talked about yesterday. This is what I want to go ahead and practice a little bit more today. Let's go and take a look at the screen. We were working through this PowerPoint yesterday, and then time ran out on us. So let's go ahead and pick it up here. Go ahead and read this problem, if you would. Audrey, nice and loud. All right, so at your seats, go ahead and set up the formula, plug in the numbers, and solve. And of course, there is a shortcut we talked about last time that may help you out a little bit here.
You interested in doing some business?
I'm sorry?
You interested in doing some business?
You need a... Tim kept it for 3 days and let it load. Quentin's finished.
I have to do this all in my head too.
What?
Do I have previous? So I get my calculator? I forgot it. I'll always have it.
You don't need
Please have it.
What's your name? You can go ahead. Audrey's finished, Jamie's finished, Chris is finished.
Always.
All right, what two things are mentioned in this problem, Kendall? Perimeters and areas. So what proportion should I write? Ooh. Genesis?
side.
Oh, but I don't have sides. Chris?
Perimeter squared.
Perimeter squared is to perimeter squared. Remember, it's areas to area, side squared is to side squared, it's perimeter squared is perimeter squared. We're just going to take the side ratio out of it, the side squared ratio out of it, because we don't have sides, right? So areas to areas, perimeter squared is to perimeter squared. And we can plug in the numbers. I know the perimeters are 45 and 18, and those are getting squared. And I know the area of the second is 20, and I'm just finding the area of the first. And this is perhaps the most natural way, just to plug it in and let the calculator do all the work. Now, it does make some awfully scary numbers. We were done with area is to 20 as, what is 45 squared, class? 2025 is to, well, we know 18 squared. We memorized that last year. 324. And of course, we cross multiply and get 324a equals 20 times 2025.
I'm not good at that.
40,500. Then we'll divide away the 324, and we'll end up getting a is equal to 125 inches squared. And there's our answer. And you might be thinking there's got to be a better way. Well, there is an easier way. For one thing, before you go squaring anything, why not reduce? What can I take out of 45 and 18, class? 9. So if you take a 9 out of both of these, that would give you a ratio of 5 to 2, which when you square it becomes 25 to 4. So a is to 20 as 25 is to 4. And now, multiply by 5, you got it. Or cross multiply and get it much quicker. So again, I'm a big fan of reducing the ratio, but even if you don't, calculator handles the big numbers for you. How many, regardless of how you did it, got 125 inches squared? Questions from those who did not? All right, Kendall, you were out yesterday. Were you able to watch the lesson? All right, questions on this? All right, let's take a look at another one here. And read this one for us, Kendall, if you would, nice and loud.
Two similar quadrilaterals have areas of 36 centimeters squared and 64 centimeters
one side of the second quadrilateral is frozen, and then you just find the length of the corresponding side of the first quadrilateral.
All right, at your seats. Solve, and then we'll work it out here in just a moment. All right, Brecken, if you would go and clear your desk, sir. First last name is 5621. How old are you, Brecken? How old are you? 16. So you were 14 years ago was 567.
Why'd you do me like that?
It's not 516, Brecken, it's 56. 56.
You were 16.
It's not a good sign for this test, Brecken. Don't write yet.
It was at this moment he knew.
Alright, should be pretty straightforward. Don't write false, right? We'll make it true. Short answer. Continues. Matching. Multiple guess.
Yes.
More matching. Essay.
Pretty much.
Alright, let's take a look at this together. And what proportion do we need to use this time? Genesis.
Area over area equals side over side.
Chris.
Side squared.
Side squared over side squared. Don't forget the squares. Area is to area, side squared is to side squared. The square of the ratio of similitude. Now we know the areas here are 36 and 64, so we can plug those in. We know the second quadrilateral has a side of 12. We need to square that class to get 144. And then I'm just missing this side squared here. Of course, we could cross multiply here to get 64s squared is equal to 36 times 144, anybody?
5,184.
5,184, thank you. And then we can divide away the 64 to get s squared is equal to 81. And we can take the square root and get s is equal to 9. 9 centimeters. That's one way to do it. There's nothing wrong with it. But, you know, a quick way to do it would be to say this. Look, all of these are squares, right? Power root transformation says I can go through and take the same root of everything, and now it will become 6 is to 8 as s is to 12. For that matter, you could even reduce further and say 3 is to 4 as s is to 12, and then you just multiply by 3, and there's your 9. So we could do it a little bit quicker without the calculator, if we so desired. But again, there's nothing wrong with doing it this way. How many regardless got the 9 centimeter answer? I have questions on this.
Why'd you multiply by 3?
Well, equal ratio method, 4 times 3 equals 12, so 3 times 3 must equal something, and in this case it's 9. You could also cross multiply and get 4s equals 36, which gives s equals 9. Yeah, it's a shortcut that doesn't always work, so that's why I don't teach it in this level. I do teach it in like the junior high level. We teach, hey, that's a way that works really nice sometimes, and then other times you have to cross multiply. By the time you get to your senior year or junior year, it's like, hopefully you already know equal ratio, but whether or not you do, let me teach you the one thing that always works, and that's cross multiplication. All right, let's do one more of these here, and read this one for us if you would, Chris.
Two similar polygons have corresponding sides of 10 inches and 8 inches. If the perimeter of the first polygon is 65 inches, find the perimeter of the second.
At your seats. Ethan, what proportion do we need to use here?
Perimeter square is to perimeter square.
I'm sorry?
Perimeter square.
Is to,
Perimeter square. as side squared is to side squared.
Okay, we could say perimeter squared is to perimeter squared, a side squared is to side squared, but something's kind of screaming at me here, Ethan, especially thinking of what we just did in the last one as a shortcut.
So
Take the square root of everything, and we actually go back to something we used on our last test, and that is perimeter is to perimeter as side is to side.
yeah, I remember that.
You remember that formula? Yeah, this one didn't require any squares at all because everything would be squared in our new formula, so nothing needs to be squared. Take the square root of everything. How many thought to take all the squares off? Okay, how many used the squares anyway? And it's fine, it'll work out the same way. But it does work out easier if you say that perimeter 65 is to perimeter, I don't know what it is, P prime, as side 10 is to side 8. For that matter, you could further reduce this down to get 5 to 4 if you were so inclined. And you could cross multiply, solve, and get what, class?
52.
52 inches. And again, it would work even with the squares, and your calculator handles the squares, so it's not a problem. But yeah, we learned perimeter side to side a long time ago for similar polygons. Since that's all that was here, there were no areas. Who needs the squares? When there is areas, when there are areas, you do need the squares on the sides and the perimeters. Questions on this? Yes, sir.
How do you know where to put the 10 and the 8? It doesn't say if the 8
Well,
is
notice the order, 10 inches, then 8 inches. So when it says the perimeter of the first polygon, that means it corresponds to the first number. Okay. All right, good. Any other questions? All right. Let's go and take a look at your textbooks now. Page 247. Page 247. Let's take a look at exercise number 2. Page 247, exercise number 2. This one takes a little bit of a different tack here. And Jamie, when you get to page 247, number 2, go ahead and read that for us, please.
Two triangles are similar in the size of one are 6 inches, 10 inches, 12 inches. If 4 inches is the side in the second triangle corresponding to the size 6 inches in the first triangle, find the other side.
It may help here to draw a picture. I'm a big fan of pictures, and we've got a couple of triangles that it tells us are similar to each other. Sides of 6, 10, and 12. And in the second similar triangle, it says there's a side of 4, Jamie, that corresponds to the side that is
6 inches.
6 inches. We need to find the other sides, which I could just call X and Y. Are areas referenced at all, class? No. The only thing referenced at all in this entire problem is sides. So really, all we need to do is figure out what is the ratio of similitude. What is the ratio of similitude, Jamie?
Would be X is to Y as.
Ooh. What's the ratio of similitude? By definition, let's define it first. What does that mean, ratio of similitude?
Oh, is it the perimeters?
Quentin, what's the ratio of similitude?
You want me to say
The definition.
size, well,
The ratio of any two
ratio?
corresponding sides in similar polygons. Well, there's only one set of corresponding sides I know.
6 to 4.
6 to 4. That's the ratio of similitude, or better yet, let's go 3 to 2. Right? That's the ratio of similitude. And then from there, that will have to be the ratio of any other two corresponding sides. For instance, back to Jamie, that has to be the ratio of
10 is to X.
10 to X. And 3 to 2 also has to be the ratio of
12 is to Y.
12 to Y. And we did this like a month ago.
Yeah.
It's just a review problem, but want to make sure you didn't get so locked in on areas and squares and all of that that you forgot just how to work with basic ratio of similitude. At your seats, find the two other sides of the smaller, similar triangle. Class, what did we get for the side X?
6 or 12.
Right, I don't want 6.666 and all that, no, 6 2/3 inches. Did they give us inches? Yes, they did. And then for side Y, 8 inches. Questions on basic ratio of similitude. You see, the only thing referenced was sides, so that's all I needed was just ratio of similitude. Questions? Do you see how that's different than the last problem we did a moment ago, which involved sides and perimeters, which again is old news. Perimeter, side is side, which was different from all the other ones where we had area is to area as either side squared is to side squared or perimeter squared is to perimeter squared. Questions? Look at number 3. Read that one for us if you would, Ethan.
The area of a triangle is 72 square inches and one side is 24 inches. If the corresponding side in a similar triangle is 16 inches, find its area.
Do you notice this time, class, it uses 2 key words, area and side. So now what proportion are we using, Genesis?
Area equals side squared to side.
Good, areas to area, side squared to side squared at your seats. Check your work. The triangle with the area 72 had a side of 24. The other triangle's area, which we don't know, has a side of 16. Make sure we keep them together this way. Now again, before you square, you can save yourself a lot of time if you will first reduce. Knock off the inches for one thing, but then 24/16 reduces to 3 halves. Which is a whole lot easier to square. You can do it without a calculator, right? 3 squared over 2 squared becomes 94. So 72 inches squared is to A prime, as 9 is to 4. And again, if you want to use that equal ratio method, you can now. What do we get for A prime, class?
32.
32 inches squared. Now again, if you don't reduce, that's fine. Your calculator will give you the 576 and the 256. And you can multiply 256 by the 72, that's okay, get a really big number. And 576 times A prime, that's easy to do in your head. Then divide by 576, calculator got that. It'll give you the 32 inches squared. Just, you know, if you don't like a calculator, like I don't, then you get to do it this way. How many have the 32 inches squared regardless of whether or not you reduced? Questions? All right, turn the page 249 now, page 249. And let's take a look at number 2, read this one for us, Genesis.
The legs of a right triangle are 36 inches and 8.1 inches. Find the area of the square on the hypotenuse.
Okay, so I actually have 2 different shapes here. Notice it doesn't mention anything about similar polygons, class. So you realize we're suddenly shifting gears and we're not doing anything like we just did. Y'all catch that? Okay, so we have to be flexible mentally here. But 2 different shapes are mentioned to me, Genesis. The 2 shapes are a
Right triangle
and then a square. So I start with a right triangle, and what does it tell me about the right triangle?
That's the legs of the right triangle are 36 inches and 8.1 inches.
36 inches and 8.1 inches. I hate decimals, but oh well, here we go. And then it tells me what about the square?
On the hypotenuse.
It is on the hypotenuse. That's all it tells me. It's on the hypotenuse. And the question is to find the area of the square. Hey, we did a problem like this the other day, I think. What would we need to do to solve this, Kendall?
Find the hypotenuse.
Yeah, and by finding the hypotenuse, I've found the length of one side, and then I can use the formula for the area of the square at your seats. And I'm going to get my calculator out now. Fortunately, it comes out evenly here for the length of the, well, evenly as in not a crazy decimal. What is the length of the hypotenuse, Genesis? 36.9 inches. And then how do I find the area of the square, Genesis?
Side square.
Right, and what is the length of one side?
36.9.
Yeah, so we just square. And what do we get for the area?
1,361.61 square inches.
There we go. How many had 1,361.61 inches squared? How many of you realized that you squared this, added the square of this, and you actually had that number? And you took the square root and then realized, I have to go right back and square it again. We technically wouldn't have to have taken the square root, because by squaring this and squaring that, you are finding that. Did you catch that? The book has, you're going to copy this for homework tonight, this theorem that if you were to construct a square on one leg, find its area, construct a square on the other leg, find its area, a squared, b squared, the sum of the areas equals the area c squared. Kind of an elaborate proof, which we don't have time to go into, but yeah, no, we could also do it the way we did it. Find the hypotenuse, square it, but it does technically work. We didn't have to take the square root at all to get this. Just, there it is. Square, square, add. Questions? How many have that answer again? All right, question. Do number 3. And what do we get for the area of our square here, Quentin?
2,304 inches squared.
Good, 2,304 inches squared, because if you found it first, the length of this side, this leg, would be 48 inches, though you may not have bothered finding it. You may have simply said, well, I know if I take the biggest square on the hypotenuse and then subtract the little square, it would equal the square here. How many, regardless of how you approached it, whether you got the 48 and then squared it, how many got the 2304 for the area? Questions on that? All right, let's jump over to number 6 now. Read that for us, Jamie.
Corresponding sides in two similar pentagons are 4 inches and 6 inches. The area of the first is 32 square inches. Find the area of the second.
Oh, you know what this sounds like?
What we just heard.
What we're doing earlier in the hour. Oh, okay, so back to that again. Mental flexibility. Do number 6. And what proportion are we using, Jamie?
The is area as side square to side square.
There we go. And we plug in the numbers. 32 is to a prime, because we're finding the area of the second. And I could say 4 squared to 6 squared, or I could reduce 4 in 6 class.
2
2 to 3, and then square the 2 to 3. 4 to 9. I could do that. Or I could square the 4 and 6 and get 16 to 36. Either one's fine. And what do I end up with for the area, Jamie?
72 inches squared.
72 inches squared. How many have that answer? Whether or not we reduced. All right, questions? Number 8. We could go ahead and square the 9 here, class, since that's the corresponding side in the second to get 81. And then we could do all the cross multiplying, or what's the shortcut here? Square roots of everything. And if you just take the square root of everything, then 64 becomes 8, 324 becomes 18, s squared becomes s, and 9 squared becomes 9. Or if you made it an 81, it becomes 9. Because it's a 9 square, just as the square root of square cancel there, square root of square cancel there, and 9. The square root of 9 squared is just 9. Should be able to solve this pretty easily, class. What do we get for s? 4. No units, just 4. 4, that's the length of the side. You could say 4 units if it really triggers you to not have units. We could say 4 units. Questions, how many had 4? 4 for this one, good. Questions at all on similar polygons? Clear your desk except for a clean sheet of paper and a pencil and a calculator. Sheet of paper, pencil, calculator. Everything else away. I'm going to end the video lesson here in just a moment. I will write the homework on the chalkboard, so if you're watching, go ahead and copy down that homework, and then of course take the quiz. The rest of the students in here will write down the homework after they have completed their quiz. First and last name at the top of your paper. First and last name at the top of your paper, along with today's date, which is 5/6, not 5/16, 5/6/21. Picking on Brecken like it's not my fault he wrote 16. All right.
Which quiz is this?
This is going to be quiz 40. Quiz 40. Just quiz 40.
Yeah, thank God.
That makes you feel better. All right, first and last name, 5/6/21, today's date, and quiz 40. 7 problems for you. I would recommend drawing pictures for several of these. You may not need a picture for all of them. Definitely write formulas. Get some partial credit that way and show all of your work. Use the quiz copy as a cover sheet. You may begin.